So now, just now we understood the concept about law of conservation of mass, right? So according to this law, we cannot create. Mass can be neither be created nor be destroyed. Only it can be converted from one form to the other form. That is nothing but law of conservation of mass. So this is a universal law satisfied by all the materials in all the chemical reactions. So here that's why definitely on the LHS side, how many atoms are there, that has to be matched with the number of atoms on the RHS. So after writing a skeletal equation, we have to check whether it is a balanced chemical equation or not. So to get the chemical balancing, here we are showing with an example, right? So here we have taken iron. So iron reacting with water to generate Fe3O4 and hydrogen. So here it is a steamed form of water. So in this case, if you observe on the LHS side, we are having iron, hydrogen and oxygen. So if you observe number of elements on the LHS, iron is 1, hydrogen are 2 and oxygen is 1. And coming to the RHS side, this is our RHS side, this is LHS. RHS side we are having iron 3 atoms, oxygen 4 atoms and hydrogen 2 atoms. So how to start this balancing? If you observe, these are not matched. Iron on the LHS it is only 1, but on the RHS we are having 3. Hydrogen on the LHS only 2 and on the RHS we are having 2. So this is a balanced one. And coming to oxygen, so we are having 1 on LHS and on the right hand side we are having 4 oxygen atoms. So how to start this balancing process is, first we choose whichever is having maximum number of atoms, right? That may be on the reactant side or on the product side. So in our case, in this example, which one it is having the maximum number of atoms? Oxygen. So we are choosing oxygen. So oxygen 4 on the right side and 1 on the left side. So how to make 4 on the LHS? So simple technique, we are having Fe plus H2O. So that gives rise to Fe3O4 plus H2. So here oxygen here 4. So here we multiply with 4 on the LHS. So now how many atoms of oxygen? 4. And how many atoms here? 4. So first step is completed. So our first equation is Fe plus 4H2O gives rise to Fe3O4 plus H2, right? Now if you observe what happens to the hydrogen atoms now, here 4 into 2, 8 atoms of hydrogen on the left hand side and 2 atoms of hydrogen on the right hand side. Now simple mathematics if you apply, here 8, here only 2. So you can multiply here this side with 4. So that is our second equation. So Fe plus 4H2O gives rise to Fe3O4 plus 4H2. This is our second equation. So in this case, 8 hydrogens this side 8 hydrogens, 4 oxygens and 4 oxygens. This much is completed. So finally, just now we came to know that Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So now we are left with iron. So here 3 atoms of iron are there. So simply I will put 3 here. So now if you observe, this side 3 iron atoms, this side 3 iron atoms. This side 8 hydrogen atoms, this side 8 hydrogen atoms. This side 4 oxygen atoms and this side 4 oxygen atoms. So now this is a balanced chemical equation. Balanced chemical equation. So why we need to balance is just now we know. So mass can be neither be created nor be destroyed. That's why we need to balance the both sides, LHS and RHS. Same number of atoms should be present. This we can do using simple mathematics. So how we choose how to do the balancing, different steps are shown here, right? So what are the different steps? In the previous one we started, first step is first write the chemical equation. So you can observe, write the chemical equation. Step 2 is first you segregate what are the elements present. Then on the LHS how many atoms are there, and on the RHS how many atoms are there. This is all about the step 2. And coming to step 3, first you start initialize the balancing equation with the so here 4 first we started with the maximum number of atoms of which element is there. In this in our equation oxygen is having maximum number of atoms, so we started with oxygen. First oxygen is balanced. After oxygen next step we came to hydrogen, and then finally we come up with the balancing the iron, right? So finally this is our balanced chemical equation. So that is 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Now writing symbols of physical states also. So this is the 6th step they are saying. So what is the importance of that one? So here we are having if you write the equation in this form, we don't know any information about the state of the materials that are formed. So what are the different types of states we will have? Gaseous state, right, and liquid state, then aqueous state, and solid state. Solid, gas, liquid and aqueous. So what are these four? You already know. So solid state means it is in the solid form. Aqueous means it is liquid diluted with water. Okay, liquid, normal liquid form. And gaseous means it is in the gas form. So in our equation, iron is in the solid form. So you can represent like suffix S. You can put a suffix with S. And then water is in the gaseous form. That means it is in the steam form here. So iron oxide is in again solid form. It is a layer kind of thing. And hydrogen is in the gaseous form. So if you write like this, the complete information about the equation we are going to understand. So even the forms of the material. Aqueous is written if the reactant or product is present as a solution in water. So that is the aqueous form. So these symbols, if you write, it will be more clear. So sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, here you can observe CO, carbon monoxide, gaseous form, 2H2, again gaseous form, and here CH3OH, right? So in liquid form it is. So here 340 atmosphere, the pressure is mentioned here. So similarly, so if you observe next one, so here 6CO2 aqueous form, 12H2O in the liquid form. So sunlight and chlorophyll, they are acting as here chlorophyll is the catalyst. So sunlight is again important for this one, right? So and what are the other products? C6H12O6 aqueous form, 6O2 aqueous form, 6H2O liquid form. So here we are representing the equation and we are saying what is the catalyst also in this reaction. Sunlight and chlorophyll are the important parameters in this reaction, right? Like this you can give the information about the reaction in the full-fledged form using a balanced chemical equation and representing even the suffixes for the state of the material.